Everybody sit correctly. Touch the ground with the elbow, both legs. Backbone is straight. Position must be opposite. Otherwise, at the age of 30, you will look like the person of the age of 20. Chulbile, chulbile, chulbile. And backbone bend like this. How will you see this one? Backbone must be straight. Master Chadara. Understood or not?
Yes, sir.
Okay, so we are discussing the chapter simple machine. Yesterday we completed two simple machines. What were they? He is doing high and sitting. Which simple machine were completed yesterday? Tell me. Pulley and scratching head. Our forearm is also a kind of simple machine. Pulley and what? Inclined plane. Pulley and inclined plane. Don't bite the nails. Have sufficient tiffin. Sit down. And remember, mechanical advantage of all simple machine is same. What is that? Load by effort. But in case of pulley, number of pulleys. In case of inclined plane, length of inclined plane by height. But the velocity ratio of single movable pulley is 2. Remember, eh? Write down. Why is the velocity ratio of single movable pulley is 2? Question is here. Why is the VR of single movable pulley is 2? Why is the VR of single movable pulley is not only is here 2 times is why? Why is the VR of single movable pulley 2? Okay, who can say the answer? The VR of single movable pulley is 2 because what's the reason? Because when the load moves once, then the effort moves twice, or the effort distance is twice the load distance. Here is the answer. Eh? I wrote the answer. They are just gappa mark sitting. What is why? Why is the VR of single movable pulley 2? The VR of single movable pulley is 2 because when the load moves once, then the effort moves twice, or effort distance is twice the load distance. Okay, that is completed. Now to present some simple machines, let me welcome on the stage today's presenter, Miss Sneha Rai. Give her a big round of applause. You can cut that one and do this.
Namaskar and very warm good morning to you all respected
Now,
subject teacher and my dear friend.
loudly.
As you all know, it's Miss Sneha Rai from grade 9 standing here to give presentation on the topic of simple machine.
A bit loud sound.
Wheels and axle consists of two coaxial cylinders of different diameter. Various examples of wheel and axle are used in daily life. Some examples of such wheels and axle are string, roller, screw drive, modani, rotating, etc. Most of them are used for magnifying effort, but some are also used to gain speed like Modani and rotating. Wheel and axle is the continuous lever. In the given diagram, a load is lifted by using a wheel and axle. The load is hung at point L at the circumference of the axle at effort is applied at point E at the circumference of the wheel. Screw is the modified inclined plane which traces a spherical line along its surface called thread. A screw is an inclined gland vapor around the cylinder. Screws are widely used in trade tester to hold objects together and in the device such as screw top for containers, screw jacks, driver and screw press. Thank you very much.
Now explain. Okay, thank you, Sneha. Give her a big round of applause. All right. So, two simple machines she have brought. She has brought. Which are they? Which are the two simple machines? One is wheel and axle, and screw. Wheel and axle and screw. Look at the diagram here. This is the diagram of wheel and axle. This big cylinder, big wheel, a big part is wheel, and the smaller part is axle. So here it is given wheel and axle contains two coaxial cylinders. Bigger is also cylinder, smaller is also cylinder. Coaxial means when one rotates, another also rotates automatically. When wheel rotates, this is wheel, this is axle. When wheel rotates, axle also rotates automatically. That is coaxial. Their center is same center. Generally, effort is applied on wheel. Where is applied here? Effort, and what is connected here? Load is connected in axle. Effort is applied on wheel. What are the example of wheel and axle? Here is given string roller. Have you seen string roller during the sign? Do they use lattai or not?
Yes, sir.
String roller. That is string roller. Okay. Next one is screwdriver. Madani. Madani you haven't seen. In village they use madani, right? Dhar dhar moi parne madani. Right side, left side, ghar. After some time, what do you get there?
Wait.
Moi down, up, now knee. Okay. Rotating, etc. And listen. In case of wheel and axle, how to calculate MA, how to calculate VR, how to calculate eta, efficiency. This is it. Efficiency is denoted by Greek letter eta. Okay. Mechanical advantage is measured by using the formula load by effort. It is obvious for everything. Remember, eh? Next one, velocity ratio. How will you find velocity ratio? Capital R by small r. What do you mean by capital R? Capital R is radius of wheel, radius of axle. Radius of wheel and radius of axle, right? And eta? MA by VR multiply by 100%. This thing you have to remember. Oh, children, remember? Mechanical advantage of wheel and axle? VR? Eta? MA by Yeah, but multiply by 100%. Okay. Here we have seen one sentence. What is given here? Wheel and axle is a continuous lever. Why? Wheel and axle name is given, but it acts like a lever. How? See here. Here is one straight line. If you draw a straight line, at the center, what is here? Fulcrum, because that is fixed point. They rotate. In one side, what is connected? Load. Another side, what is connected? Effort. Swing balance or effort, right? So, what type of lever is it? First class lever. It acts as first class lever. When the effort is applied, then the axle rotates continuously till the load reaches at the top. Rotates continuously. That's why what is it called? Continuous lever. Question can be asked sometimes. Remember, why is wheel and axle called continuous lever? In wheel and axle, load, fulcrum and effort, they lie in straight line. What do you say? Load, fulcrum and effort, they lie in straight line. When effort is applied on wheel, the axle rotates continuously till the load reaches at the top. That's why what is it called? Continuous lever. Okay, write down somewhere else. Why is wheel and axle called a continuous lever? No, first I'll say from the beginning. Why is wheel and axle called continuous lever? Why is wheel and axle called continuous lever? Now answer. Wheel and axle is called a continuous lever. Axle called a continuous lever. High. Crystal high. Wheel and axle is called a continuous lever because effort, fulcrum and load lie in a straight line. Effort, fulcrum and load lie on a straight line. Fulcrum and load. Effort, fulcrum and load lie on straight line. When the effort is applied on wheel, then the load rotates continuously. The axle rotates continuously till the load reaches at the top. Continuously till the load reaches at the top. Hence, load and effort is called a hence wheel and axle is called a continuous lever. Hence, wheel and axle is called a continuous lever. Okay, they have done that one. Now next number is here. What is the question? What is the heading? Screw. So here is cylinder. This long one is cylinder, and something is on here. Yes or no? So what is the definition of screwing? Screw. An inclined plane wrapped around the cylinder is called screw. What is the definition? An inclined plane wrapped around a cylinder. Suppose here is one cylinder. Cylinder, what is this? Cylinder, and one inclined plane is wrapped like this. Now it becomes screw. What are the different examples of screws? Example of screw. screw jack, driller, screw press. Screw is present here also. Is a screw? No, but screw is here. Check. Are here screws or not? Inside also screw, here also screw, so they can be fitted. Rotate. Down, no screw. Yes or no? So screws are present in different places, and there is one device to unscrew the screw nail that is called screwdriver. Have you seen?
Yes, sir.
Driver. Screw jack. Here is given screw jack. Screw jack is used for lifting the vehicles. Sometimes the vehicle's tube gets punctured. Yes or no? To change it, it must be lifted or not. And if we ask some people to lift, then they feel tired. But one device is used. What is that? Screwdriver. On the screw jack, not driver. Screw jack. Now, what is the formula to calculate MA, BR, and eta? This is quite important. How will you calculate the mechanical advantage of screw? Load by effort. Load by effort. Mechanical also this is the same thing. MA by BR multiplied by 100%. Only BR differs. What is the formula to calculate BR? ED by LD. But here is no ED. 2 pi R by P. Is it? 2 pi R by P. What do you mean by this 2 pi R? Pi value is constant. What is the value of pi? 22 by 7 or 3.14. What is R? R is radius? Radius of this upper one, right? And what is P? P means distance between the two threads. This is P. P. Here is R. Okay? 2 pi R by P. What is R? Radius of the head of screw. P. Distance between two threads. Distance between two threads. Now let's check in the book what is given there. I'm going to open the book now. Book is here. Is the class 9 book open or closed? Here is class 9 book. So some numerical problems were already discussed. Machine. Mechanical advantage. Velocity ratio. And after some time I will check your work also whether you have done or not. Sorry? What am I? What are you talking? What is this? Hello, which device is this? Bigger device is called? Small devices? And you can see some depression or not? Low part. That is called groove. What do you call it? Groove. So through that rope can pass, right? And here VR is given 2 pi R by R, or we can write RR only, R by R. Then next one, it is the numerical also. Screw. This is the example of screw. So R, radius, and radius of this one is here. Now P means distance between two threads. Screwjack, driller. I think this is okay. That is all. And next day, which presentation is there? The person will present wedge and compound machine. Wedge and compound machine, and chapter will be over. Right? Now, 5 minutes. 5 minutes. Will you read these two numerical symbol machines? Afterwards, I will give you some tags. Okay? Please start reading now.